Hello, welcome back. In this chapter, we'll be taking integration by substitution of trigonometry substitutions. Shige. So it's still by substitution, the same method, but now it is trig functions that will be making use of. Initially, our trig functions are sine x, cos x, tan x, cot x, cosec x, and then sec x. So integration by substitution of trig functions is divided into two. We have by coefficient, and then by power. But when we say by coefficient, what does it mean? It means in place of this x in our normal trig functions, there are other numbers there, 4x, 5x, replacing x. That is, a function is acting as the domain in our trig function. Example of by coefficient: if I say integrate sine 4x, initially it should be integrate sine x, but something else is acting as the domain, which is 4x. So to integrate this with respect to x, we say let u be that function representing x, comma, then du dx will be what? 4. If we make the x the subject of the formula, you have it to be du over 4. Then if you have to write your question back, you have integral sine u. Why? Because 4x is being replaced with u. Then what is dx? Dx is the same thing as du over 4, which I can bring my 1 over 4 out to be a constant. 1 over 4 integral sine u du. So if I integrate sine u with respect to u, I'll be having minus cos u. So it has 1 over 4 minus cos u plus c, which is the same thing as minus cos u over 4 plus c. But what is my c? My u is the same thing as 4x. So my answer is minus cos 4x over 4. Another question: what if the question is integral? What if the question is integral cos 4x squared, integral cos 4x squared plus 1 dx? Still the same method. You say let u be the domain, the function acting as the domain, then you differentiate it. I have du dx, which is equal to 8x. If I make dx the subject of the formula, I have du over 8x. Then my question will be called integral cos u du over 8x, which is the same thing as 1 over 8x integral cos u, with respect to what? With respect to u. So I have it to be, if I integrate cos u with respect to u, I have sine u. That's 1 over 8x sine u plus c. But what is my u? Automatically I have 1 over 8x sine into bracket 4x squared plus 1 plus c, plus 1 plus c, final answer. So that's integration by substitution. But the smart method behind it says that instead of using the long method, in case you are dealing with complex integrals, instead of disturbing yourself finding this method, you can just go straight to the point by saying integral sine 4x dx is equal to differentiate your domain. When you differentiate your domain, you have 1 over 4. Take the inverse of it. That's you have 4. If you differentiate this, you have 4. Take the inverse of it, you have 1 over 4. Then if you integrate your sign, you have cos minus cos. That's times minus cos. Then write your 4x back. Final answer. Similarly to the other question, which says integral cos 4x squared plus 1, you don't have to disturb yourself. Since it is with respect to x, differentiate your domain or the composite function there, differentiate the function acting as the domain, which is what is in front of the trig. If you differentiate this, you have 8x, take the inverse of it, I have 1 over 8x, then differentiate, integrate your cos, you have sine, and write your bracket back, plus 1. So other question, what if I ask you to integrate cot into bracket 4x plus 3x squared? So using the method, you should be able to get the answer to this. Well, write the answer out so that you will be able to confirm if you get it right. So try that on your own. That's ln sine into bracket 4x plus 3x squared over 4 plus 6x. Try that out and I'm very sure you will surely get it. So that's integration of trig, integration by substitution of trig function. That by coefficient. But when we say by power, it means your domain, your function remain the same, the trig function remain the same, but is having a power on it. Example, sine integral sine square x. This x will not change. It's only this that will have a power on it. So, and also in case the x change, there's a way you can solve it. But if the power, you can still integrate this. Initially, there's no way you can integrate by power, integration of substitution of trig functions by power. But when you move into reduction formula, then you'll be able to integrate them. So there's no way you can integrate this for now. But since it is raised to power 2 and we have knowledge of basic identity from trigonometry, so we can convert it from power to coefficient. So to convert this from power to coefficient, I can say, recall trigonometry functions that says that cos 2x is equal to 1 minus 2 sine square x, right? Okay, that's multiple formula for cos 2x. If I ask you to make sine 2x the subject of the formula, I'll be having 2 sine square x is equal to 1 minus cos 2x, then sine square x is equal to 1 over 2 into bracket 1 minus cos 2x. So automatically, since sine square x is the same thing as this, then I can say the integral of this is the same thing as the integral of this. So I'll be having the integral of 1 over 2 into bracket 1 minus cos 2x dx. This 1 over 2 is a constant. I can bring it out. I have 1 over 2 integral 1 minus cos 2x, which is the same thing as 1 over 2. If I integrate 1, I have x. If I integrate cos 2x, then I have sine 2x over 2. We've solved it above, with us by coefficient, integration by trig function of coefficient. So from the knowledge of by coefficient, you should be able to integrate this. So if I open the bracket, I have x over 2 minus sine 2x over 4. Final answer. Thanks.